Hey guys, today we are going to start our 7.3 section, which is independent and dependent events. So first I just want to go through our notes that we have in our foldable. So independent events. It's when an occurrence of one event does not affect the probability of the other event. So it would be the probability of A and B, and we can write that as the probability of A times the probability of B. So if you roll a number cubed twice, the first time you roll, you could get any of the 6 numbers. The second time you roll, it doesn't matter what you got on the first one because it's not affected. So those are independent events. Okay? Now, for dependent events, this is when the occurrence of one event does affect the probability of the other event. Okay, so this is based off conditional probability. And we write it as the probability of B given that A already happened. So this little line right here, you say given that. Okay, so down here we have probability A and B, and they're dependent. Okay, so they depend on each other. So we would do, okay, well, the probability of A times the probability of B given A actually happened. So this is like if you had a deck of cards and you picked a card and you left it out, okay? The second card that you draw is dependent on the first one because one card is gone already. All right, for our examples that we're going to go through, we are going to find the probability. Okay, so this is a little spinner. So what's the probability of spinning a 4 and then a 4 again on the spinner? So you look at your spinner and you say to yourself, well, how many 4s do I see? I see 1, 2, 3 out of, I have 4 on this side, 4 on this side. So that would be 3 over 8. So my first spin to spin a 4, my probability is 3 over 8. The second time I spin is independent because it doesn't matter what I spun the first time. So the second one, it wants me to spin another 4, so that's another 3 over 8, and we're going to multiply them to get 9 over 64. Okay, so the probability of spinning a 4 times the probability of spinning another 4, we're going to multiply. That little and, we know we multiply. The next example, spinning red, then green, and then red on a spinner. Okay, so spinning a red, how many reds do I have? I know there's 8 total. I have 2 reds. So I have 2 over 8, which I am just going to write as 1 over 4. Okay. Then I have a green. How many greens do we see? 1, 2, 3 out of 8. So I'm going to write it down here. Times 3 out of 8. Okay. And then another red. Okay. So I have 2 reds out of 8. So that 2 out of 8 I'm going to reduce to 1/4. And we're going to multiply them all together. 1 times 3 times 1 is 3. 4 times 8 times another 4 is 128. Okay. The next 2 examples are number cubes. So, rolling a 6 on one number cube and a 6 on another cube. Okay. So we have 2 different cubes that we're rolling. They are independent of each other. The first one will not affect how I roll on the second one. So you have to say to yourself, all right, well, I know there's 6 sides. So I know that's my denominator. And if I roll a 6, well, there's only 1 6 on a number cube. So it's 1 over 6. And then the probability of doing it again is going to be the same. 1 out of 6 chance. When you multiply them, 1 over 36 is our answer. All right, our next example, tossing heads, then tails when tossing a coin 3 times. So a coin has two options, a heads or a tail. So the first one I want to toss is a head. So I have, okay, 1/2 chance of getting a head. Then another head. Well, that's another 1/2 chance. And then a tail. Another 1/2 chance. So to get them all, it's 1/8. That's our probability. Okay, let's move on. Now we have, two number cubes are rolled. Okay, so number cubes, remember they're 1 through 6. 2 of them were rolling. One is red and one is blue. Explain why the events are dependent, then find the indicated probability. All right, so our example A says, the red cube shows a 1 and the sum is less than 4. Okay, so let's look at it as, all right, my red cube I just rolled is a 1. Okay, I have a blue cube. What are the blue options if the red is 1? Okay, well, my blue options are 1, 2, 3, 4, 5, 6. Okay, so if my red, I rolled a 1, the blue, it could be anywhere from 1 to 6. Okay, so the probability of rolling a 1 in red, if I'm doing 2 number cubes, remember, 36 is my total. Okay, so the probability of rolling a red 1 would be 6 out of 36, which reduces to 1/6. Because I have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. These are 6 combinations where I could do a red 1. So 1 out of 6 is the probability of me rolling a red 1. The second part is, all right, well, I want the probability when the sum is less than 4, given that I rolled a red 1. Okay, so we're going to use the same numbers. We rolled the red 1, and now I need to know the probability of getting a sum that's less than 4. I have 1 plus 1, and I have 2 plus 1. I can't have 3 plus 1 because that is 4, and it doesn't say less than or equal. It just says less than 4. So that is 2 over, I only had 6 options to start, so that's a 6, and that's 1/3. Now what you have to do is we have to put them all together. So rolling a red 1 is 1/6. After that's rolled, getting a sum of less than 4 is 1/3, and I'm left with 1/18 of both of them happening. Okay. Our next example. The blue cube shows a multiple of 3 and a sum is 8. Okay, so we're going to do the same thing. So the blue cube, I could roll a 1, a 2, a 3, a 4, a 5, or a 6. Okay, what are the multiples of 3? Well, I have a 3 and I have a 6. So to get a multiple of 3, the probability of a multiple of 3 is going to be 2 out of 6, which I reduced to 1/3. Now, I want the sum that is 8. So if I rolled the blue, I'm going to make a little chart over here, blue 3, what are the choices for my red? Again, I have 1, 2, 3, 4, 5, 6, and I have 3, 3, 3, 3, 3. All right. And I also have the 6. So my blue and my red. Okay, so if I have a 6, I have all of these options. Okay, so out of all of these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 total. Okay. And which ones add to get 8? 5 plus 3 is 8. 6 plus 2 is 8. So 2 out of 12, and I'm going to reduce that to 1 over 6. So we're going to combine them. 1 over 3 times 1 over 6, and it just happens to be 1 over 18 again, just like the last problem. Okay? Our third example is we are going to read a chart. Let me go out a little bit. Okay, here's our chart. All right, so these are Texas counties with the largest votes for president of 2004. Okay, so we have our county, we have the voters who voted for Bush, we have the voters who voted for Kerry, and then we have voters who did other. So the first one, it says, okay, well, I want the probability that a voter from Tarrant County voted for Bush. Okay, so that is the probability a Bush voter, given that they are in Tarrant County. Okay, so I'm going to look at Tarrant County. Okay, I am going to add 349, 207, and 3 to get 559 as my total. Now, of all of these Tarrant County voters, how many voted for Bush? That's 349. So that is your answer. Okay, so when we look at tables, don't automatically add everything inside. You have to read and say, what are they asking me? Okay, the second example, that a voter voted for John Kerry and was from Dallas County. So here, first, I want all the voters that voted for Kerry. So I'm going to add this column up, all of my Kerry voters. Okay, when you add that up, you're going to get 1,422. And was from Dallas. So of all these Kerry voters, how many were from Dallas? We have 336. And that's our answer. Okay, good luck, guys.